well, on the bench today I've got a Maxcom Super 4E, which comes with the green display, obviously Super 4E, and then I've got my test radio, which is a Maxcom 4E. This one's perfectly working. This one's got a fault, it's got no transmit on it. It's also got one segment out for the upright 4. You can see there for 39, 40, 20, if we go down to 10, so you can't, that should be 19. That's another fault, but at the moment I'm trying to concentrate on the no transmit, and what I found out is I cannot adjust the VCO voltage to get the thing into lock, and I've been trying to find out where this 16 megahertz signal is coming back that needs to feed in to the chip on pin 19, which is F in. Then you've got the 10.240 megahertz frequency coming in. The two of them get compared, and if they're okay, then it locks with the binary code. Now, what I've discovered, luckily using this radio as a standard to follow where the relative voltages are, if I look here, you can see for channel 1 I've got 16.90585, and that's the frequency you need feeding in to the VCO. If I probe on the radio here in the same position, the radio's not in lock. I've got 16.903, 901, 902. So I'm in the right area, but it's free flowing. Now, you probably can't see this, but if you jump across to the other side, there's a transistor straddling here with the 3 legs going round between the 2 lots of pads on the end. You've got 2 resistors and a capacitor. Now, on this radio, if I measure there, as I've shown you, 16.903, go to the other side of where that band is, 5.85. So the 16 megahertz signal has disappeared across those resistors and that capacitor. Do the same thing on the other working radio. Hang on. Right, 16.90586. Straddle across. 16.90586. So the signal carries across that bridge, but it doesn't on this other one. Now, the components that I've got, looking at the circuit diagram, and I will zoom in to show you, are R156, Q113 and R155, all, oh, and C198, all of which go to pin 19. So the frequency going in to the LC7137, the PLL chip, is being stopped in this area here. It's not making it to the pin, and that's why I've not got lock. So now I've got my desoldering tool on here. I'm going to desolder those components, put them on the tester and see which one's faulty, and hopefully we've solved the problem. Right, I've got the transistor out. This is an MB9426. So let's try that in here. Helps if you press the button. That's come up as a resistor. Okay. That looks a bit odd. Okay, let me just have a look what that should be. Okay, so I've soldered in the MPS 9624 or 92, what is it? Hang on. It's an MPS 9426, and I've used the C variant. The difference between the B that was in there and the C is the C has a higher gain, so it's okay to use it because I'm going for a better gain. I can't go to a worse one, so I couldn't have gone to an A. Now, if I now probe pin 19 of the PLL, 16.90593, so the 16 megahertz signal is now getting through to pin 19. If we go on to channel 40 and we probe the pin again, we've got 16.912. We should have 17.995, I think, or 9205 or something. But what that indicates is the VCO's out of lock, so I need to quickly tune the VCO and see if I can get this into lock. Okay, so the next problem is that the VCO has now got the 16.8 megahertz signal on both, but when I key up I've got no TX. Now if I quickly put the probe onto the VCO transistor, which is here. Okay, so I've hooked up a probe now that's now holding that there. As you can see, we've got 16.90586. If we key the microphone and go into TX, VCO changes to 13.876. It's moving about a bit because of that probe I've got just balancing on there, bodged on a bit of tape. Okay, but it's changing by 3 megahertz from receive to transmit. Let's try it on the other radio. Right, so I've got the radio there. I'll key the mic now. Nothing. And you can see we're not going into TX. We've got no TX at all, and we've got no down mix signal. So again, the radio won't lock because we haven't got that TX signal either. So we need to look at the transmit receive circuit now. What I've noticed in the book is there's a TR control, transmit receive, and that's the one that changes from 16.9 to 13.8. So we need to find that transmit receive control, which I'm thinking is going to be a transistor, and follow the 16 megs through. Now the microphone from here goes through a band pass and limiter into a deviator into the VCO, and it says 13.8 megahertz in. Well, we haven't got that, so we need to see if we can pick up on that. So I'm going to start at the mic wiring and start coming through and see if I can trace it. Well, there's the problem. It's just broken in half. So we're going to test that. So I suspect that was probably broken before I even touched it. So there lies the problem. Let's push this down through here. That's not coming out of there, is it? Here it is. Yeah. Oh. You seem to have fallen over. So there's the two halves of the resistor. Now, I didn't really handle that badly, so I suspect that was already broken and we just couldn't see it. All the banding's gone off the outside as well, so that's another good indication that something wasn't right. So anyway, we'll crack on. I'll order some parts and I'll be back when the parts arrive.